Let's talk about this problem. We are given a doubly linked list. We need to reverse it. So if our doubly linked list is 10, 20, 30, 40, where our hat pointer is pointing to 10, we need to reverse it and make it 40, 30, 20, 10, and our hat pointer should be pointing to 40. So when we say we want to reverse the linked list, we mean that earlier 10's previous was null and 10's next was 20. Now 10's previous is 20 and 10's next is null. If you look at other nodes, their previous and next pointers or references are also changed. So we need to make these changes in the linked list. Now please pause this video and try to write down a function that takes head of a doubly linked list as an argument, reverses the doubly linked list and returns the new head. Let us talk about the solution. We are given this linked list. Head is currently at this node and we want to convert this into this linked list. 40 should be the head. For 10 or head, we have next as 20 and previous as null. And what we want in the modified linked list, we want next of 10 to be null and previous to be 20. So what all we want to correct or fix this node, we just want to swap the previous and next pointers and or references, pointers in C and C++ and references in Java. So we just want to swap these two. After you swap these two, your next of 10 becomes null and previous of 10 becomes 20. Now you move to 20 and 20's previous is 10 and 20's next is 30. In the modified linked list, this is your head and 20's next should be 10 and 20's previous should be 30. So we again need to swap previous and next, right? Then we get this linked list. We get the next of 20 as 10 and previous of 20 as 30. Now we move our current to the next node, 30. And if you see this 30, again you need to do the same thing. In the original linked list, previous of 30 is 20 and next of 30 is 40. But in the reverse linked list, what do you want? You want next of 30 to be 20 and previous of 30 to be 40. So we again swap previous and next. Now we come to the last node. And if you see the last node, we again want to do the same thing. In the original linked list, next of last node is null and previous of last node is 30. But in the modified linked list, we want previous of this node is null and next of this is 30 because this is going to be the head of our reverse linked list. So the idea is simple. Traverse through all the nodes of the doubly linked list. For every node that you traverse, simply swap previous and next. There might be some corner cases, but you can handle them easily. They are not complicated corner cases. So please pause this video now and try to write down complete function that reverses a doubly linked list and returns the head of the reverse linked list. So here we have C++ and Java implementations. In both the implementations, we are first handling a corner case which says that if the linked list is empty or linked list has single node, then return head, return the old head. No need to change anything. Why are we handling this case also separately? Because at the end we are going to return previous arrow previous in C++ or previous dot previous in Java. We'll understand this whole approach and why are we returning this step by step with an example of a 3-node doubly linked list. So as we discussed earlier, we are simply beginning with current equal to head, right? And we are running a loop while current is not null, and inside the loop we are swapping current next and current previous. First we get current previous in previous variable, then we assign current previous equal to current next, then we make current next equal to previous, right? So this is just swapping previous and next, and for swapping you need a temporary variable so that you can swap the two pointers or two references. For temporary variable purpose we have used previous, and this previous is also going to help us to keep track of modified head of the reversed linked list. After swapping previous and next, we move current to next node. See, we are doing current equal to current arrow previous or current dot previous, not current next, because we have swapped to previous and next, right? So whatever was next now becomes previous. Let's see a 3-node doubly linked list, and here I have shown the arrows this way, that the previous arrow is this side and the next arrow is this side, right? So we have this doubly linked list initially current is here and previous is null. After the first iteration, what happens is previous and current of this node are swapped. So its previous now becomes 20 and its next now becomes null. Its previous was null earlier, right? And what are we doing now? We are doing current equal to current previous. So current now becomes here, right? Because this is 20 is now previous of 10. So current now comes here. Previous is still null, right? And now we do the next iteration. When we do the next iteration, after the next iteration, what happens is previous now becomes 10, because we have previous as current previous, and current previous is still 10, right? So previous now becomes 10, and its next and previous are swapped. So its next becomes 20 and its previous becomes 30. After swapping previous and next for 20, we move current to 30. How do we move? We make current equal to current dot previous arrow previous, and 20's previous is now 30, right? So current now comes here, and where is previous? Previous is at 10, right? So this is what we have after second iteration. Now we begin our third iteration, and in the third iteration we get previous by doing current dot previous current arrow previous. So previous is here at 20 after the third iteration, and now we swap previous and next for this. So its previous becomes null and its next becomes 20, and you can notice that all of your doubly linked list nodes are swapped, right? Corrected, right? And this is now ready to become head, right? Its previous is null. That's what should be the previous for first node of the doubly linked list, right? It's going to be the first node in the reverse doubly linked list. Its next is 20, 20's previous is 30, 20's next is 10, 10's previous is 20, and 10's next is null, right? So everything is done. And now what do we have? We have current as null and we have previous at 20, right? So, and we have come out of the loop. When we come out of the loop, we return previous arrow previous or previous dot previous in Java. See, previous dot previous means 20's previous, right? 20's previous is going to be 30, right? Because our if I show this doubly linked list diagrammatically, it's going to be like this: 30, right? If I just correct the arrows, rewrite the arrows this way, it's going to be like this, right? This is going to be our reverse doubly linked list, and this is going to be our head node, right? That's what we are going to get after reversing the doubly linked list. Let's now quickly understand why do we have this case handled explicitly. If you have a single node doubly linked list, then what will happen? Previous and next will be swapped, and after swapping you will have previous still as null, right? And null arrow something accessing is a problematic, right? So we have this case explicitly handled so that we don't have those problems. Also, this solution requires only one traversal of doubly linked list and requires constant auxiliary space.